Good morning again, everyone. This morning, I have the incredible pleasure of introducing and having with us here Sir Tim Berners-Lee. Sir Tim Berners-Lee invented the World Wide Web. That should be enough. I should just walk off. But he's done more. He has also created and led the World Wide Web Consortium, the W3C, that has shepherded the standards for the web for almost 25 years. And as part of that, he also added a layer of data to the web for pages, a web for data, that we know as the Semantic Web. That's very relevant for what we're talking about today. I didn't know this, but he told me that over a third of the pages on the World Wide Web actually have data embedded in them, and that all the major search engines actually crawl for that data and create their own graph of all the information that's out there. Amazing stuff. As the web became bigger, he also co-founded with Rosemary Leith the World Wide Web Foundation to make sure that the web is accessible for everyone, and for those that it is accessible to make sure that it remains open, that it remains constructive, that it goes in a purposeful direction, and to serve humanity. He's also a professor at MIT and at Oxford, and he's been pioneering research there in re-decentralizing the web, keeping it true to its origins, and led a project called Solid about making sure that people are in control of the privacy of their own data. So, without further ado, let me welcome on stage Sir Tim Berners-Lee.
Thank you. Wow, it's great to be here. Thanks for having me. Great to hear previous talks and learn something about all this new technology myself. So application networks and the web, you asked me to talk about. And it's been interesting because I've been thinking about how they're different, but also about how they're similar, in fact. So I've been working with, I suppose actually I did it before my project at CERN. I have to say, before the World Wide Web, I worked on RPC projects, remote procedure call. You know, it's an early precursor of APIs, and so I've sort of been there and done that in a very crude fashion at CERN with putting together programs by calling different things, although at that point we were calling functions which worked right down in the bottom of the pit, at the bottom in the accelerator. So to a certain extent, over the last 30 years, APIs and data and documents have evolved. In some ways they're similar, in some ways they're very different. APIs, the goal is to put together eventually a huge successful computation. You've got a big function, you've got the IT of your business which you're putting together. With data and documents, the idea is to put together, well, data actually is to do with knowledge. That's why when we talk about the semantic web, we mean it's not just about the computer keeping track of bits of human readable documents and the words they contain. It's about human understanding, it's about the computer understanding what that's about. So machine readable acquisition of building knowledge. In both cases, I suppose we need the connectivity. Everything we build runs over the internet. We need to have it open, we need to have it neutral, we need to have it secure. Whatever the systems are. In both cases, I suppose, when you're looking at the world of building big data systems and we have discovery. Somebody else must have done this already. Where is it? With code, I spend a lot of time going to my favorite current package manager, NPM, asking NPM to install things, pulling in huge amounts of stuff that other people have written, other people have tested, and building things very quickly by pulling in modules. When you do the same with data, then you're going out looking for, you're going to something like LOV. You're looking at people who list databases of databases. You're going to the linked open data cloud, the LOD cloud. You're looking at a list of, somebody must have, what sort of area am I on? Who will have pulled in all this data together? Pulling together public data, pulling together public code. Completely different, in some ways the same. In both cases, self-describing. APIs, readable, being one in a series of API description and interface description languages which go back through the ages. And then if your data is in the RDF model, you have the RDF schema language, you have the ontology language OWL, you have shape languages like Shackle and Shex, which allow you to describe the shapes. So these are things which allow you to make things self-describing. So in both cases, you have this self-describing world, and in both cases, you've got this open community. You've got the open source community on the side of APIs that will allow you to just populate the API and all the other APIs it depends on down the chain. And then you've got the open data community, which will allow you in a different sort of way, not so tree-like, maybe more graph-like, but the open data communities, a whole community, a really part, by the way, even if you feel that your enterprise the enterprise is the place for you, that's where you add your value, that you're providing, helping enterprise manage their data. Actually, when somebody in your company is making a decision about what to do tonight, they will be looking at corporate data, yes. But actually also, it's very important that their calendar will pull in their personal data as well. And it's also really important that they pull in the public data. They pull in that feed from their favorite band. They pull in the U2 concert so they can think, okay, interesting new stuff going on MuleSoft. How can I fit that in with the U2 concert? The MuleSoft may be proprietary data. The U2 concert is public information. Both really, really important for one person's life, for one instantaneous decision of what to do that night. You've got to be able to ensure they don't overlap. So integration of data in data, it's integration across the whole range of what we call the data spectrum, from the very personal, very private, to the very public. Treated in some ways very differently, but in some ways, sometimes you merge it all together. An individual person's got to be able to see them all together, not just for calendar data. That should happen for all the data, all types of data in life, I think. Both things can be read-only or read-write. There's a lot of valid times when you give somebody, you give all your customers a read-only access to your catalog, whether it's an API for wandering through your products, or it's open data. There's times when you just give them read-only data. But there's times when you realize that the supply chain, if you could actually share information or allow people not only to annotate the products with the things, give them allow your customers to put their star ratings on your products, then you're sort of opening up making more of a two-way communication. Things like the supply chain tend to work better as a two-way communication when you've got feedback going both ways. So often it's interesting to look at something when there's a read-only API. For example, when on the data side, when the town dumps out there the list of all the things they need to fix in the roads, they have the pothole database. Rapidly, they discovered that the other side of open data is actually making that a read-write database, saying, okay, this is our current set of databases. Mind you, if you see anything that if you know of a pothole that we don't know of, then please put it in. And in fact, that attitude of changing, making the list of things that have to be done in the community a read-write thing, that can be not just an efficient way of maintaining the town's to-do list effectively, but it can be a change of emphasis, a change of attitude to running this town. It's something that's got to be done, and it's going to be done in collaboration between the citizens and the town. And so actually having a read-write space of data where we can together share that list of possible problems and tag onto it the list of possible solutions. Oh, don't worry, that's outside my door. I will chop that tree. Don't you guys do it. I'll handle that. I got that one. It turns the whole, it can make the whole, not only make the computer system more efficient, it can make the town more efficient because you're using people collaboratively better, and you're doing it by giving them a collaborative shared space of read-write data. So read-write, the read-write, read-only things are good to visit and revisit. I suppose you could say, well, hang on, it's crazy. You're comparing these things. They are so chalk and cheese. So in some ways, yes, they are very different. We're talking, in one case, you're talking about APIs, you're talking about functions, you're talking about procedures. You're talking about code. You're talking about stuff which it's procedural. That fundamentally, where's the data? No, data, that's procedural. This is declarative. Those are opposite ends in computer science. Everybody spends their time having attacks of loving procedural, having attacks of loving declarative. People spend their time trying to convert things that they've done in a very procedural way and make them more declarative, or sometimes drive it the other way. Then they realize that they have a wonderful procedural system, which actually is best done by prioritizing it, and the parameters are just data, and so that they can build declarative systems which run off that, and so on. So, in a way, procedural declarative has been one of the just two facets, two ways of looking at the world, two sets of tools that you need, two sets of sort of differently colored spectacles with which you can look at any problem. It's interesting that think about procedures, functions, then good function design is all about data hiding. In a way, the most important thing when in your favorite programming language you make a function is you wrap up the function and all the internal variables you hide. Some languages, you hide them automatically. Sometimes you hide them by convention. But the whole point is that when I call your function, I don't have to worry. You don't allow me to mess with the ways, the intermediate values, because you reserve the right to change the way it works afterwards. So you're going to just do something. You're going to provide a certain functionality. You're just going to convert this thing from one format to another, and all the intermediate values, or you're going to make a decision about whether this is a good one, whether this is one we're going to take or one we're going to throw out. And all of the intermediate values which you arrived at, you keep to yourself so that you can change those algorithms afterwards. So information hiding is big part of the concept of functional programming and APIs. And whereas information sharing is then what everybody talks about with data. With data, one of the issues for a lot of us in the world is that we've got data. We have, on a good day, we have data like the calendar. We have personal data that I control. I have my own personal calendar. I have things I share with people very close to me. I have team and group calendars in all these various organizations you've heard I'm associated with. I have calendars which I share with them, and I have these public calendars. And I have and it turns out that with calendars I can share fairly well. I can give people rights, but that only works for calendars. And it only works because calendars support this rather weird and historic CalDAV protocol that only works for calendars. What's wrong with this picture? Shouldn't it work for everything? Shouldn't I be able to do that with my context? Shouldn't I be able to do that with my pictures? I think there are people all over the world who are quietly at the moment frustrated by the fact that they have friends on Facebook and they have colleagues on LinkedIn and they have photos on Flickr. And if they want to share the photos on Flickr with their friends on Facebook, then they have to upload the pictures to Facebook. And if they want to share them with people on LinkedIn, then they have to use LinkedIn. And so they're actually in these silos. So because we've got these silos, our ability to share information is very limited. If I want to share something, if I want to allow I delegate somebody to access something at MIT, then there are a set of people who have MIT certificates. They are within the MIT system. I can't give an arbitrary one of you. If you want to look at photographs that I've got on the MIT system, I can't use that authentication system because MIT is never going to give you a user account in that space. So I can't use any of those facilities to share apart from the MIT world. If you're really sure that what you're building is a silo and you want to build a HR system which is really a silo, then fine. But actually, it turns out that when you look at most organizations internally, there is a desperate lack of value. There's a missing opportunity from being able to say, oh, So that is health data. I will share it with my doctor, and I will share it with the people in the ambulance who come to rescue me when I'm dying in the street. And also, I want to share it with my family, these particular members of my family, even though they're in a different country, they're in a different continent, they're never going to log onto the same hospital system. They have a completely different hospital system. But I want to use their global identity to give them access at all times to my medical history. And only those members of the family, not these members of the family. I want to be able to take arbitrary people. I want to be able to say, yeah, I want to be able to sort out for my medical history, I'll share it with my family. But the list of appointments I have with doctors, really important to share it with my assistant, because she's the only one who actually controls my calendar. And so to set up a reasonable life, some things need to be shared with some people. And so one of the things that we're doing at MIT, with a new project called Solid, is saying, imagine if all your data was like the calendar. Imagine that all the data was such that you could store it in any store. You could store it in you could use any application to use it, because in fact, instead of having specific APIs, we're saying we'll have one big generic API, which is just the ability to read and write arbitrary structured data. And so in the Solid system, I can you can give me your card, I can take your ID off it, I can give you access to anything. And we just, in fact, Uri and I found we found that we had a friend in common, and I could, because this guy uses the Solid system, I could give him access to the meeting I just had with Uri. So these are exciting times that we're going to break down those walls between these silos. I think that you'll find, whereas I might preach to people about breaking down silos between the big social networks, and a lot of people out there might resonate, you might look at your company and realize actually the divisions with my company or the departments within my government, actually they behave pretty much like you're talking about companies. We have our own silos. Never mind us being a silo, we have our own internal silos. That's often what people say. So I think it's exciting times. I think when we break down these silos, I think we're coming to we are getting to a point where there is actually enough frustration with privacy not being respected, enough frustration with me not being able to use my own data myself, that I think we are ready for revolution. And Uri, where are you? Why don't you come out here and let's talk about it with these good people. Thanks for your attention. Hey.
Swapping us out.
Right.
All right. Awesome. Hearing straight from the source. So this morning, I wanted to start off with a little bit of a personal anecdote. It's kind of an embarrassing moment, but I'm used to being embarrassed on stage, so I'll just keep going. In 1991, I was sitting in Lawrence Berkeley Lab with a beautiful view of the Bay Area with my next computer working on my physics, and I had a bunch of applications on my desktop, Gopher and other things that many in the room have heard and others don't have any idea about. And this little application popped up called the World Wide Web. I looked at it, I'm like, don't understand this, clicked into it. I was a theoretical physicist. There was a bunch of experimental physics results from CERN, and I'm like, okay, this is another attempt by the experimentalists to raise their visibility, and I hit delete. I had deleted the World Wide Web application from my desktop. I didn't realize the revolution that had just been launched by the creator of that program and all the infrastructure under that. And I think that's actually really relevant for us today, because you don't realize revolutions when you're in them, when they're going, when you're just in the midst and everybody is contributing without necessarily understanding that. And I thought we would kick off maybe the line of questions to Tim about, what was it like historically? And maybe we kind of shift a little bit. We've had a little bit of feedback from the audience of questions they're really, really interested in. So I'll adjust a little bit what we were going to talk about. Maybe take a little bit more historical route to help our audience understand what did it take to actually bring the web to life. How did this happen?
Well, deep frustration with the existing situation, I suppose. I did first degree with physics, and in physics, I didn't use physics at CERN. I was just a software engineer there. But physicists are taught to generalize. An apple falls. If you drop an apple, it falls. If you drop it again, will it fall again? Is there something we've got consistency? Is there some rule there? So to a certain extent, what I was looking at, you put out the generalization. I look at all these different documentation systems that were running on different. There were many computers at CERN. It was a wonderful time for diversity in IT. CERN didn't have any big sort of military-style dictatorship over IT. So all the individual groups came from different universities. They brought different Macs and PCs, different mini computers and and then they used the CDC and the IBM mainframe. So everybody had a favorite system, and everybody wanted you to write your documents in their favorite. Was it Word? Was it Tech? Was it HTML? And store it on their favorite store and index it with their favorite index and use their favorite UI to get it. And so there was as I saw it, a desperate need for me just to be able to function in the place. I wanted to be able to have all that stuff. I wanted to be able also, I wanted to be a read-write. The idea was it should be a read-write space. I wanted students to come for the summer and be able to just arrive in June, look around the web, figure out, understand what was going on, understand all the reasons for the decisions that had been made, contribute, work hard for 3 months, adding in all their stuff into the web, and then leave without having to debrief them. So that was the sort of frustration to actually. I managed to get permission to do it as a side project, and then I had to persuade everybody it was a good idea. Lots of people like you went, yeah, but a group of a surprising number of people, and a surprising number of people on stage have since sort of recalled with chagrin that moment. But in fact, a very small number of people did pick it up. But that is all it takes. In this group, I can tell you about the revolution, and I don't need all of you. I don't need 90% of you to go and believe the revolution to help with it. All I need is I see a few sparkles in your eyes, okay? And then a few people will go home, right, and say, solid.mit.edu, check that out. A few people will then come to Decentralised the Web conferences, and they may be small, but then they're passionate because they get it, and there are a few people early on who got it. That's how it took off. Yep. So people like Tony Kuntz at Slack were not very far from you, and he picked it up, for example.
Right. So I think one of the really brilliant things about this, and really a lesson I would guess for the audience, is to pick your battles, to say, there are certain things that we do have to standardize, but you didn't go and tell everyone, go and rewrite your documents in this standard way. You basically said, I will, keep going the direction that you're going, but follow a small number of protocols, and if you do that, then the rest will basically self-assemble. How do you decide what is good to standardize on, and what is okay to leave as is, maybe in your existing silos?
So I think the one word for that rule is universality. It should be able to work with everything, any computer system and so on, any language, it should be universal for people with accessibilities and so on. So universality meant it should be able to work with any existing system. So what I thought was, okay, the key thing is the name of the object. Now you call it a URL, I call it URI, a universal resource identifier. Is the thing which starts off on HTTPS and ends with hash something. The idea of that, you have to give everything that. That is the one thing you have to do. So when a lot of them start HTTP colon, in those days, HTTPS colon now, but they don't have to. And in fact, one of the things I think is, okay, it's really important that we can move on from HTTP to the next thing on. So what I'll do is I'll put this, this scheme and the colon, and we'll put HTTP now there, but actually we'll also put an FTP colon, and FTP will give you a way of making a URL pointing into the whole of the existing, all these FTP servers. So suddenly we turn all the existing file transfer protocol servers into things which could be addressed with URIs. So we brought on board all that legacy stuff by folding FTP space into the names, by inventing a way of making up a URL for anything on FTP, and a few other things, Gopher as well. So we put in the flexibility point. The idea is if the colon there, that flexibility point allows us to switch out HTTP into something else. So we did switch it out for HTTPS, and there are lots of things like SAFE and IPFS coming down the line that we can install in there. So the first thing is, yeah, you do have to use URIs, but you don't have to use HTTP. You can go, we'll do our best to design a good one. And when you use HTTP, then you send down a list of, the client, the browser sends down a list of all the formats it supports in the accept header. It says, I accept these things, and you can say you could accept all kinds of newfangled things. You don't have to do everything with HTML.
So there's a negotiation that's actually going on.
So in HTTP, there's a negotiation, so it's one round trip. You said, these are the things I accept, and then the server says, okay, I'm going to give it to you in HTML. I'm going to give it to you in RDF. I'm going to give it to you in PDF. And so already it was, you don't have to use HTTP. But if you do use HTTP, you don't have to use HTML. Really, you can put it in, and people did. And people still do. And the Semantic Web took off because we said, okay, we just add into the content negotiation. Say if you can handle it, if you're looking for data, then we can turn it into these data formats. We've got hypertext, and we've got linked data. They are sort of they're equal things on the web. There's no the web has no bias that you have to be doing HTML with it.
So that's a great segue to the next step, which at some point you realized, I need to actually inject computer-readable data over this web of human-readable pages. And you somehow managed to get enough people to embed data to get this idea going. What do you think was important to get that to happen?
Well, I didn't do it by myself. That's really interesting. 2009, I did a TED talk saying raw data now. I got people jumping up and down in the TED stadium saying raw data now, because the frustration then was, you'd go to a government website, you see the web page, you download the PDF of the report, and in the PDF of the report, there'd be this chart. And actually what you wanted to do, you wanted to pull the data into a spreadsheet. And so as a journalist or as a student or as a scientist, you couldn't do that. So I said, you should publish the data. You should publish it in a machine-readable fashion. And so that was a big push to get people to publish the data. So the open data movement was successful partly because we got support from Gordon Brown. We had lunch with him. He said, yes, what should UK do? I said, get the government data online. And he said, well, do it. OK, yes. And so the UK just kind of did it. Much more complicated story, but long story short, the UK did it. US, UK were competing to put government data on. Corporate data also really, really important. So there's been this, to a certain extent, one of the things has been the revolution in open data. And if you look up the linked open data cloud, the LOD cloud, go Google it, look at the way the linked open data cloud has grown. So that has partly been, there's been a huge amount of linked data that you can, in the public domain, that you can go to. And then meanwhile, Google, some of the folks at Google have been saying, oh, the data on the web will never work. But actually, meanwhile, with schema.org, check out with schema.org, they started to blog that, well, there's this way of, if you put linked data into your web page, if you use things like tools like RDFA, that's RDF in HTML attributes. RDFA allows you can publish a web page, and you can say, oh, by the way, we're talking about a product here, and this is its price, and so on. If you do that, then the Google search engine will not just put it into index of documents, they will put that into index of products. And then they will set up your own comparative shopping for you, because they will understand this is a product. So the value of the semantics was so much. So that meant that more than a third of web pages, I gather, out there at the moment, well, a few years out of date, they have some sort of semantic web compatible microdata in there that Google scrapes out. So that Google now has, so there's a huge incentive if you want your stuff to appear, you want your search engine to know that it's a product, to know where it's deliverable to and from, and what the price is, and so on. So there's an incentive. So in fact, now the microdata say there's a huge explosion in that. So there is a huge amount of semantic web data, and you could tell the moment it became important because the search engine, which you remember the search engines used to just have a list of things. You'd search for Paris Hilton, and it would give you a list of web pages, and you'd see some of them would be about Paris Hilton, the person, someone would be about a Hilton in Paris, and as a human being, you'd sort of pick one to follow, but then pretty soon, with Google, then it has this giant global graph of data, and they put an info box, and the info box is all semantic web stuff. Okay, they're saying, okay, we're talking about a thing which is a hotel that is of RDF type. It is a hotel. Look in schema.org, this is a hotel, and this is a person. This is a celebrity, and we have information about the celebrity and have information about the hotel, and we'll help you buy it. We'll help you reserve a room in the hotel if you want. So the change people, when those info boxes crept into the search box, that was a visible sign of really the semantic web having been coming to becoming a very powerful thing.
And we've been active students of what made the web so successful, what made semantic web successful, because really our intent in partnering with our customers is not to build tomorrow's legacy, but to actually build long-lasting systems and put in methodologies and put in approaches that actually stand the test of time. And I think the ultimate one is actually the web, right? The most complicated system we've created so far that's lasted us and grown and keeps innovating on itself. I think one of the critical observations that we made in our conversations backstage is this realization that when you're thinking about data, not only is being exposed these days through APIs, through open data, but also thinking about it as a distributed graph, a decentralized graph of data, that you first need to actually surface it in a graph mindset so that you can actually assemble a bigger graph out of that. I think that's absolutely critical. Maybe share a little bit of your thoughts on that.
Yes, sure. I suppose partly the graph, the reason why the semantic web stuff was designed as a graph is because not everything fits in a tree. Typically, if you see two tree-like XML sources and you merge them together, you ain't got a tree anymore, folks. You can't just serialize the result as XML. You take two JSON feeds, you merge them together. You can't just serialize the result. In fact, what you have to do is to build the graph, and then you re-serialize the graph. So partly it's because the graph model is the most general. All relational data and tree, everything can be mapped into the graph. When you're doing the integration, then you might pull in data from all kinds of different apps. But then what is cool is then when you put it into a graph, then you can use a graph query language to be able to ask questions that you could never ask before. You ask the graph query languages, even though some of the data came from a rectangular database, some of it came from a tree-shaped thing, some of it came from all kinds of other shapes. When you put it together, it's just a graph. You can ask a really interesting, insightful query, which just goes across those arcs of the graph, no matter where they came from, and brings you out an insight. And so some of the really people I've seen sort of talk about their really fun times when they blew management minds with the system was when they took a big graph triple store in the graph query language and then run queries across it and put it into visualization, and suddenly people looked at the company and went, oh, whoa, what's going on here? So being able to do work, in other words, put one mindset on when you're working locally with the data, right, and put another mindset on when you're working with the whole thing, put the phone together.
Right. And I think if I follow kind of the dialogue you've been carrying, you start from realizing that there are silos, and rather than saying, well, let's throw them out and let's rewrite everything in a standard way, you allow those silos to be discovered by thinking about them as nodes on graphs. You come up with some standard protocols to allow people to at least discover and communicate and negotiate how they get that data. And then I think the last step, in a sense, is when that graph is open to the right community, you don't keep it private, but you actually open it. Maybe it's to your internal developers, maybe it's you share it with some partners, maybe you make it truly open. Then the question is one of innovation. And again, you've advocated the direction of permissionless innovation, permissionless access. Maybe talk to us a little bit about how that's kept the web going all these years.
The permissionless space, the concept of a platform. The internet was invented back in 1969. I was writing the memo about it would be a good idea to have a thing like the web in 1989. So 20 years. For 20 years, the internet had been built. It had been built by Vint Cerf and colleagues, and they had built it as a platform. Like, what do I mean by a platform? I mean something which is solid, something which has got a very well-defined API. You have the socket API, which allows you to open a connection from one place on the internet to another place on the internet with information hiding about all the gory details about how they connected together. So clean, straightforward. And they didn't think, what should we use this? What should this be usable for? What should we design this thing? They said, let's just allow any two programs to communicate. So it didn't have an attitude. A good platform doesn't have an attitude of what you're going to use it for. So it was decentralized. There was no central point where I had control, where I had to go and register the new protocol. I did have to pick a TCP port number to use. The client and the server just had to agree on a port number. I picked 2784 because that was my parents' phone number, so at least I could remember it. And so that's all the permission I had to ask.
Now we know where that came from.
Decentralized development. The web, similarly, the intent has been also, you don't have to ask me to make a new website. You just go ahead and do it, really. Do tomorrow. And so you make a new website, and you use the fact that we've got the internet platform as one level, the web platform as another level. They are both just platforms. They're just designed to do the work, do the donkey work of connecting these things, as we say, and leave it up to your imagination to decide what you're going to build on the platform.
Yeah. Now, what I think is particularly interesting, and I don't know how intentional this was, is that when somebody adds their own thing to the web, permissionless, on their own motivation, there's also enough structure in there for other people to build on the work that first person has done, and you start to get these network effects. Was that actually intentional in the original design, or is that something you discovered later?
Actually, it's something we've been thinking about a lot more. We'll talk about picking battles with ontologies at one point as well. But I suppose there's a fork. Sorry, what was it called? What was that?
So did you plan for people to be able to build on the work that other people had pulled in and kind of get this engine going?
I think one of the interesting things that happened there was the psychology of the individual people worked with the technology to make it spread. So the reason people were very excited about the web back in the day when the blogosphere was the word on everybody's lips, when everybody was blogging, because this is what it was like to blog. Okay, you bought a computer, you bought an internet connection, you bought the software to run a web server and to run a blog, which isn't rocket science. You just had to have put some HTML files in some folders, and then you'd write a blog. And when you wrote a blog, you would link to other people's blogs, and you would try to make your blog as good as possible, and you try to link to really, really interesting blogs. And you knew. Why did you do that? Why was it? Why were people trying so hard to make their blog really, really cool, really, really interesting, and link to such good stuff? Because they wanted people to read it. They wanted two things to happen. They wanted other people to read it. They wanted the little Google Analytics click counter at the bottom, pre-Google Analytics even, the click counter at the bottom, to keep rolling on. They watch that. People are reading it because they're just psychological urges to be read. And also, they wanted people to not only read it, they wanted people to link to it. Because if people linked to it, then people reading other blogs would come, and that would build up. So they became a community of people who would link to each other's blogs if and only if they were really good. And so there was a feeling that everybody was working to make the blogosphere just a more and more interesting place and a bit higher and higher quality place. And that was the way the psychology of people, the need to be read, and the mechanics of the link worked.
And I think there's a lot of lessons here for organizations in trying to say, have you thought through the incentives of individuals, their individual personal motivations? Is there something in there that, for example, if you want to affect massive organizational change and you want to do that by having everyone kind of play in one direction, what is their incentive to actually do that? If there is an incentive, if there's a reward system, if you want people to be consumption-oriented, right, so that they care about the consumption and their incentives are about that, then guess what? You get a very consumer-friendly structure even inside of your, organization.
Case, you've got the consumer incentive is aligned with producing the overall wonderful blogosphere or the wonderful, just like the wonderful Wikipedia. Then the flip example is suppose you make, again, you make with all the best intentions, you say, we want people to be able to use all the data we've got about our users to be able to make very, very good target decisions in targeting the ads. We want the ads to be very efficient, and we want them to be the sorts of things which really appeal to users, because for users, we don't want that space to be wasted space. We want the ad bar to be something which is full of really useful ideas. And so we will make the targeted advertising system as efficient as possible. What could go wrong? And we will make it available to anybody who wants to sell products. And why shouldn't we make that available to somebody who wants to sell a product if that product is a political idea or a political party? And so, in fact, you can build, with all the best intentions, you can build a system which actually, maybe we'll find out, turns out to be decreed to be something which democracy can't take. You know, in France, you're not allowed to advertise if you're a political party, period. In the UK, you're not allowed to advertise on TV if you're a political party, okay? Because TV was felt to be too powerful and too manipulative, and you can't, and anyway, it's no good if you allow the political speech to be bought with dollars. It should be given in equal quantities to each candidate. So there's a whole, so if you go along that way, you know, you can imagine we should now go back to social networks and say, actually, in future, just for the sake of democracy, to preserve democracy, we had to turn off your system because it has ended up producing a horrible polarized world in which people are horribly distrustful of each other.
So there's unintended consequences as well.
So when you're building a really large system that scales to billions of people, watch out for the unintended consequences. It's not as simple. It's really complicated to understand how these systems work.
So maybe we'll spend the last minute and a half, if you can talk to us a little bit about where the World Wide Web Foundation is actually going, right? World Wide Web has such a profound effect on our lives that I think you've been heavily invested in also trying to help it go in a better direction, make sure people have access. Maybe tell us a little bit about that.
So the Web Foundation came out of the realization among the tech crowd that I was with that, oh my goodness, 20% of the world are using this thing. You know, wow, isn't that cool? Became very quickly, what about the other 80%? So there's part of the realization was that when you make the web even more cool, when you make the search engine even more powerful, and so on, then for the 20%, yeah, fine, you're making it more powerful. Say you're increasing the digital divide. So to a certain extent, you're making the world a worse place in that you're making it a more unequal place. So the Web Foundation was about two pieces. It was about, what about the other 80%? So the Web Foundation is about access. It's about how can we try to get, at the moment we're talking about 1 for 2, you should be able to get a gigabyte of mobile data for less than 2% of your income. So that's in some countries like Nigeria, they've actually got that, but a lot of countries they haven't. So that is about access, but it's also, meanwhile, we realized that we couldn't just, for the people who have got access, we can't rest on our laurels and particularly after the last couple of years, and look back, job well done, you're okay. The only thing we had to do, I used to say to people, you can use the web for 99% of your life, but for the other 1%, you have to fight for net neutrality. Because it all depends on we use this platform, and that platform uses that platform, but for 1% of your life, you have to fight for the openness of that platform. Well, it turns out you have to fight for a lot more than that. One, we fought for net neutrality, and we got net neutrality, and whatever happened to that? So we have to go back and fight for net neutrality again. Boring, but yeah. Boring but true. You have to go back, and in this country, you have to go down to Washington, and you have to right now call your congressman about net neutrality. Whoever thought we'd have to do that? But it's not just net neutrality. Of course, there are all kinds of other things. There are all kinds of threats to the web. There is surveillance. There is surveillance which, for example, in the UK Prime Minister decided that it's more important that the police can spy on, can have the ISPs track your web traffic than it is personal privacy, although or more important than the fear that all your list of all the web traffic that people in your family have gone should become public. So there are lots of things. So there's lots of stuff to fight. We had a campaign called Web We Want, which is asked people about what sort of web do we want. That was around the 25th anniversary of the web. Folks, we're coming up next year to the 30th anniversary of that memo. At the same time, that 20% of the people having the web, actually it is now becoming 49.99999, watch this space, people are on the web. Sometime in November, do become part of the celebration. It's a sort of, well, I think we're going to have a celebration as we flip over to 50% of the people on the web. At the same time, more or less, we'll be celebrating, and then a few months after that, we'll be celebrating the 30th birthday of the web. Right. And we need to celebrate it by really launching a huge efforts to protect it. And we never realized that at the 30th birthday point, we would have to put so much effort to protecting the piece. So we're at the 50-50 point. We need to work on access for that 50% and the web that we want, a real open web that we want our kids and our grandkids to develop for the other half.
That's a great going message. Please join me in thanking Sir Tim Berners-Lee. Thank you for joining us.
That's Web Foundation people.
Yes, thank you very much.